So, hello everybody. Sorry for the podcast not being uploaded into the YouTube because we are having something to do. So now we resume the operations, and this week we are going to talk about this question, which is question 21 in Project Euler, namely amicable number. So let's see the question. Okay. So let D be defined as a sum of proper divisors of M, which are the numbers less than n, which divide evenly into n. If A equals to B and DB equals to A, where A is not B, then AB are amicable pairs. For each A and B are called as amicable number. So it sounds a bit confusing now. So we will see the example here. So proper divisors of 220 are 1, 2, blah, 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 blah. And therefore, after summing up the numbers here, and we get 284. So we'll try to get the proper divisors of 284, which are the number as follows. So after summing the numbers up, you will get back 220. So evaluate the sum of all amicable numbers under 10,000. So, okay, the solution is pretty stupid because I'm using force now. Firstly, we need to get the number, look through the every single possible numbers under 10,000, which is 1 to 10,000, but 10,000 isn't included because it is under 10,000 here. This is the question's requirement. So I have function here get amicable number, which is the sum of the proper divisors for the number. So in this case, I use I, therefore this is B will be the sum of the proper divisors for the number I. So the function is defined as so. So initially we set the sum equals to 0, which is count, or you can use sum or whatever you like. So next, I'm going to look through the factors, which is from 1 to n minus 1, which is expressed here, because n number is less than n, which divide evenly into n. Therefore, we are not going to include n as the proper divisors of n. So if the number can be divided by n and it is equals to 0, I mean the remainder is equal to 0, so we will add the sum, as the I is a proper divisor of the number n. And after looping through the integers here, then we will get this, it will return the sum. So eventually the sum will go to b. Okay, so if b is less than 10,000, why? Because it should be less than 10,000. Let's say I have a number and it gives over 10,000, then this condition would be invalid. And b is not equal to I, because this is also caused by the question requirement that A is not B. And next, we'll, after checking through these true conditions, we'll start checking the reverse of the number. So after getting the after putting the number A inside the functions, we get number B. Now we will get the number back. So we put B inside this function and it will get back the amicable number. And if the amicable number is equals to A, which satisfies this equation, or maybe this expression, so we will total up the amount, which is stated here. Evaluate the sum of all amicable numbers. So in the end, we print out the total. Yes, 31,626, which is the same here. So yes, so that's for this question. And eventually you might use something like this. Yes, you can eventually use I plus something like this. And if num is a square root, then add, sorry, not square root, it's perfect square. Perfect square, then add the square root to the sum. Yes, for this method it is faster, but if you can handle that complexity, it's definitely better than the solution I have here. So this is what I can think of this question. So see you in next section. Okay, goodbye.